All right, here we go with our Unit 6 test review. So starting with Target 1, remember Target 1 is being able to identify a rational function from a graph or equation. So from an equation, we're looking for two things. You have the entire function is a fraction, and within that fraction, what's most important is that you have a variable like x in the denominator. The second part of the target is to be able to identify a rational function from a graph. And there's lots of ways you could phrase this. Um, there's two symmetric parts to these graphs. You could talk about that exists because there is a horizontal and vertical asymptote. Make sure that whatever you write here, it allows you to be able to identify an equation from a group of equations and a graph from a group of graphs. All right, moving on to target 2, so the constant of variation, so essentially the slope of a rational function. So one way you can approach this target is through using this formula, y equals k over x. So to use that formula from a graph, you're going to start off by picking a point that's on your curve. So I'm going to pick -4, 3. And you're going to plug the values in for x and y. So in the equation, we have y equals k over -4. And if I want to solve for k, I would multiply both sides by -4. And I would get k equals -12. However, we've also talked about that you can just actually multiply your x and y coordinate. So I'm going to continue with that shortcut. On b, if you're finding the constant of variation, it's whatever's in the numerator. So it's just 8. And so again, you can just multiply, instead of using that formula, the y equals k over x, you can just multiply the x and y coordinates, and that gets you your k value. If you're given a table, it doesn't matter what you multiply. You should be getting the same thing every time you multiply the x and y coordinates. So in this case, the k value is 18. For targets 3 and 4, we're going to be graphing a rational function. And so as a reminder, your vertical asymptote comes from the denominator, and it's always the opposite, so it's x equals -4. For your domain, it's everything but your vertical asymptote. So you can actually do those together, and then we can go ahead and graph that vertical asymptote at -4. The way I remember that the domain and the vertical asymptote go together is that they're both associated with x. So the vertical asymptote is x equals, and the domain deals with your x variable. This number at the end represents your horizontal asymptote. Make sure you write y equals -3, and then your range is going to be all real numbers, but y can't equal -3 again. So horizontal asymptote and the range are both associated with y, so that's why they pair up. So then I'm going to go ahead and graph a horizontal line at -3. To finish this problem, we have to make a table of values. And I'm going to pick two values to the left of the vertical asymptote. So the vertical asymptote's at -4. Two values to the left would be -5 and -6. And then two numbers to the right. So I'm going to choose -3 and -2. And I'm going to plug those into the original equation. So replacing x with -5 would give me a -9. If I replace x with a -6, that would be -6. With a -3, that would be 3. And with a -2, that would be 0. So I'm going to go ahead and plot these points. So -5, -9, -6, -6, -3, 3, and -2, 0. So they should look kind of symmetric about each other. And when you connect your points, make sure you don't cross or touch either of your asymptotes. If you feel like you have to cross or touch them, then that means your points are not in the right place, or your table's wrong, or something's going on. Also remember, our numerator is a positive 6, so you can see it's going from the lower left hand to upper right hand, so it has that positive numerator pattern. Just always to check your work. All right, on target 5, we are matching rational functions. So lots of things that you can do in order to match. One thing I like to do to start off with is I like to go through and think about what will be the vertical asymptotes. So I'm going to write the vertical asymptotes of each of these. So what I'm doing is looking at the denominator and switching the sign. So far, all of them have different vertical asymptotes. I think now we have 2 negative 2's. And then we have 2 3's. So I'm going to hold off on the problems that I'm circling because they have the same vertical asymptote as another problem. And I'm going to go ahead and match everything that we have left because those are all unique vertical asymptotes. So I'm going to start off by looking at our graphs. So on this first one, number 13, that has a vertical asymptote of 3. I'm going to come back to that because that's one that's the same. On number 14, it has negative 3, so that must go with number 20. So I'm going to put 14 right here. On 15, it has a vertical asymptote of negative 2. I'm going to come back to that because that's one of those repeats. I'll cross this out for process of elimination sakes. On 16, it has a vertical asymptote at negative 2. So again, coming back to that one because that's one that's the same. On 17, it has a vertical asymptote of negative 1. So I'm going to go back up and see where I had a vertical asymptote of negative 1. And that is number 14. So this goes with 17. Continuing on number 18, there's a vertical asymptote of positive 2. So I'm going to come back up here. Positive 2 is number 13, so that must go with 18. Number 19 has a vertical asymptote of 0. So which equation had a vertical asymptote of 0? Also 19. 20 has a vertical asymptote of negative 4. So looking for that up in the equations. 21 has a vertical asymptote of 3. I think that's one that's the same. Yeah, so I'm going to come back to that. And then 22 is a vertical asymptote of 1. So 22 must go with 17. Okay, so now I have 4 equations, 4 graphs left. So I'm going to go to another characteristic that I could use to differentiate these equations and graphs. So I'm going to look at the horizontal asymptote. So if you look at 21, the horizontal asymptote would be y equals 3. And when we compare that to number 16, that horizontal asymptote would be negative 1. So while 16 and 21 have the same vertical asymptote, they do have different horizontals, so we'll be able to differentiate those. So I'm going to look at 15, the graph. It has a vertical asymptote at negative 2, but I can see that the horizontal is at 3. So I can match that with number 21, which means for 16, I'm looking for the only other vertical asymptote at negative 2, which is 16. Okay, and I'm going to do the same idea here with the remaining 2 problems, so number 18 and 22. 18 has a horizontal asymptote at 3. 22 has a horizontal asymptote at negative 2. So I'm going to look at the graphs we have left. Number 15 has a vertical at 3, a horizontal at negative 2. So that's got to be with 22. And then number 18, the equation 18 must go with the only graph we have left, and it does, 21. So I just used the horizontal and vertical asymptotes in order to help me. You could have done the horizontal before the vertical, whatever works for you. Moving on to target 6 and 7, so we have to be really careful in this grouping of problems because there's some multiplication and some division. We do handle them in a similar way. but we do have to remember if it's division to multiply by the reciprocal. So we're going to start off by factoring what we can. So think about this as 4 separate problems. On the first numerator, we're going to look for numbers that multiply to 5 and add to -6. So that would be -5 and -1. You can use the shortcut, so please go ahead and do that. In the denominator, numbers that multiply to -35 and add to 2. That would be +7 and -5. In the second fraction, we can't factor anything. There's no greatest common factor. They're not quadratic, so I'm going to leave it the same. And then we cancel out things that are the same on the top and the bottom. So n-1 cancels out, n-5 cancels out, and we are left with our final answer, which would be n-9 over n plus 7. All right, so in number 2, we're going to approach this in a similar way. We're going to first think about factoring these. So the common factor in the numerator is a 6p, which would leave us with p plus 10. In the denominator, numbers that multiply to 50 and add to 15, that's 5 and 10, so p plus 5, p plus 10. Now I've covered it up, but this was actually a division problem. So remember, we have to multiply by the reciprocal. So I'm going to multiply by flipping the second fraction, p plus 5, I can't do anything with that, and p plus 1, which I can't do anything with. So p plus 10 cancels out, p plus 5 cancels out, and I'm left with the final answer, 6p over p plus 1. So number 3 is also division, so I'm going to keep that in mind. Can't do anything with n-6, it's not a quadratic, there's no common factor. Same with n-10. I am going to change the division to multiplication, and I'm going to flip the second fraction so that n plus 3 comes in the denominator. Numbers that multiply to 10 and add to -11 would be -10 and -1. And then cancel out what's the same on the top and bottom. So the numerator still has n-6 and n-1, and the denominator just has n plus 3. For number 4, it's also division, so we have to multiply by the reciprocal. So starting off with the first numerator, a-9, we can't do anything with that. We're going to factor the denominator, so numbers that multiply to -40 and add to -3. That would be a-8 and a plus 5. And then I'm going to multiply by the reciprocal of the second fraction. And I'm always looking for opportunities to factor. a-8 cancels out, so I'm left with a-9 in the numerator and a plus 5. It's technically times 1, but if you multiply it times 1, you just get a plus 5. Number 5 is multiplication, so I don't have to worry about flipping the second fraction. So looking for opportunities to factor. I can factor the second numerator, so numbers that multiply to 56 and add to -15. Oops, wrong variable. Would be -7 and -8. Still over 4. Things that are the same in the top and the bottom. It just leaves you with x minus 7. There's nothing in the denominator. You could put it over 1 if you wanted to. So number 6 is division, so I am going to flip the second fraction as I'm rewriting. So starting with the first numerator, numbers that multiply to 21 add to 10, 7, and 3. Notice all these problems that we've been looking at, you can use the shortcut, so make sure you're identifying that. And then multiplying by the reciprocal of the second fraction. And then cancel out what's the same on the top and the bottom. All we're left with is a 6. Again, you could write that as 6 over 1 if you wanted to. Number 7 is multiplication, so I'm just looking for opportunities to factor. Can't do anything with the first fraction. With the second fraction, that numerator, I'm noticing there's a common factor of 2v. And there's a v plus 6 in the top and the bottom. If you write your answer, notice that 2 over 6 actually simplifies to 1 over 3. And if you have v over v squared, that would just be nothing over v. So make sure you take that extra step to simplify a little bit further. So on 8, the first thing I'm noticing is that this first denominator kind of written funky. Normally we write our x squareds first. So I'm going to write it like that. I'm going to just rewrite that denominator. And now I'm going to go ahead and start the problem. So this is division. I have to keep that in mind. The first numerator is just x plus 2. Now that I've rewritten the first denominator, I'm going to factor out the common factor of negative 8x, which would leave me with x minus 5. And then multiplying by the reciprocal, 8x squared minus 40x has a common factor of positive 8x, which would leave me with x minus 5 over 1. So x minus 5 is the same, and also 8x is the same, but don't lose that negative. So you can write your final answer a couple different ways. You can write it as x plus 2 over negative 1, or you can actually divide both of those by negative 1 if you would like. Either way. And then on number 9, we're multiplying. So same concept, just different numbers. I'm looking for opportunities to factor. I'm noticing there's a common factor of 4 in that second numerator. And then things that are the same on the top and the bottom. So that actually just leaves me with 5p squared. If you want to put it over 1, you can. And careful here on this next one, it is division. So thinking about factoring and also multiplying by the reciprocal. So the numerator has a common factor of 20. The denominator has a common factor of 40. And then multiply by the reciprocal, so that would be 8 over 8a squared. So a minus 1 cancels out. 8 cancels out. And then if you think about 20 over 40, that simplifies to 1 over 2. So in the numerator, all we have left is a 1. In the denominator, we have a 2a squared. If you get to your final answer, always make sure that your final answer is completely simplified. So for example, if I wrote my final answer and I still saw that I had 20 over 40, we know that that simplifies to 1/2. So you can do that in a couple different steps if you want to. All right, moving on to target 8. So very similar to target 7 when we are dividing. So think of this as a fraction divided by a fraction. So this is the same as saying x plus 1 over x minus 4 divided by x minus 4 divided by x plus 1. So just writing it in a different way, which means that our job would be to factor anything and also multiply by the reciprocal. So x plus 1 over x minus 4. And I'm looking for opportunities to factor, but I'm not seeing any. And it's really tempting to cancel these things out, but they're not the same on the top and the bottom. So our final answer is actually just x plus 1 times x plus 1 over x minus 4 times x minus 4. And you can leave it just like that. So on number 12, if I rewrite this, I would have a minus 1, which I can't factor, over 5 times the reciprocal of the denominator. So that would be a minus 1 over 5. Again, I can't cancel anything out. It's just the same on the top and the bottom. So in the denominator, instead of doing 5 times 5, actually writing it, I'm going to go ahead and multiply them and say that's 25, just to clean it up a little bit. Same idea here on 13. So we have m over m plus 2, which I can't factor. I'm going to multiply that by the reciprocal of the denominator. Nothing cancels out, so across the top that would be 3 times m. Across the bottom, m plus 2 times 1 is just m plus 2. And then our final target 8 problem, x minus 5, which I can't factor, over 9. Multiply it by the reciprocal, so 3 over x minus 5. So this one, some stuff does cancel out. So then you have 3 over 9, which we know simplifies to 1 over 3 as our final answer. Always looking for opportunities to simplify. All right, our last target is target 9, and so our goal here on target 9 is to solve, check for extraneous solutions, but in order to do that, we do need to have a common denominator. So the first thing we're going to do is look at any denominators that are able to be factored. So think of that as over 1. Our second denominator is just n, so we can't factor that. But our last denominator, I'm going to write in the factored form, which would be n times n plus 1, so taking out the common factor of n. So then I'm going to rewrite the problem. So we have 1 over 1, and I am giving myself some space for a reason, but I am just rewriting. I'm not doing anything new here. All right, so now we need all the denominators to be the same. So the first denominator needs an n and an n plus 1, which means the numerator does as well. Whatever you give to the denominator, you have to give to the numerator. The second denominator just needs an n plus 1, which means the numerator just needs an n plus 1. Once all the denominators are the same, then you can create an equation with just the numerator. So going across the numerator, we have n times n plus 1 plus n plus 1 times n plus 1 equals 2n squared plus 4n minus 6. So now I'm going to solve this. So I'm going to distribute the n, so n squared plus n. And then if you multiply together n plus 1 times n plus 1, you get n squared plus 2n plus 1, still equal to 2n squared plus 4n minus 6. Combining like terms over here on the left, that would give me 2n squared plus 3n plus 1. So if I subtract 2n squared, you'll actually find that those cancel out. So then I could subtract 3n and add 6 over here. So I would end up with 7 equals n. So if 7 equals n, I'm going to go back, check for extraneous solutions. 7 does not make any of the denominators equal to 0, so that is good to go. Same idea, different problem. None of my denominators on number 16 are factorable, so I'm going to go ahead and start by rewriting the problem. So I need all the denominators to be the same. So I'm going to multiply in a v minus 2 here. This one needs a v. And then this one also needs a v. So once the denominators are all the same, I'm going to multiply, or I'm going to write the equation across the top. So that would be v minus 3 times v minus 2 minus v times v plus 3 equals v. So I'm going to multiply out v minus 3 times v minus 2. So if I FOIL that, I get v squared minus 5v plus 6. Now I'm going to distribute a negative v, so that would be negative v squared minus 3v equals v. I'm going to clean up what we have on the left. So v squared minus v squared cancels out. So I have negative 8v squared, or negative 8v plus 6 equals v. I'm going to add 8v over. So I get 6 equals 9v. And if I divide by 9 and simplify that fraction, I get v equals 2/3. And I'm checking to make sure that would not make any of my denominators equal to 0, and it would not. So working on number 17. So the first thing I like to do is factor any denominators. So I'm going to factor this denominator. I'm going to do this over to the side, and it's going to give me 2v plus 1 and v plus 4. So use your factoring skills to factor that denominator. I'm going to check to see what that number is. V minus 3. Yeah. Okay, so now I'm going to rewrite my equation. So I have v minus 3 over 2v plus 1 equals, let's call that a 1 over 1, minus 1 over, I'm going to use the factored form, 2v plus 1 and v plus 4. So my goal is to get all the denominators the same. So a couple of them already have a 2v plus 1. So this one would need a v plus 4, which means the numerator also needs that. The next denominator actually needs both parts. So does the numerator. And then the last one doesn't need anything in there because it already has both parts of the denominator. Once all the denominators are the same, we can just write an equation across the numerator. So that would be v minus 3 and v plus 4 equals 2v plus 1 times v plus 4 minus 1. So I'm going to multiply out. So using FOIL, that would give me v squared plus v minus 12 equals, if I FOIL those two together, I get 2v squared plus 9v plus 4. Don't lose that minus 1. So I'm going to go ahead and combine like terms. So I'm going to subtract v squared. I'm going to subtract v. And I'm going to add 12. So that would actually give me a 0 over here because I've gotten rid of everything. That would give me a v squared plus 8v, and then that would be plus 15 if I combined all those like terms. This is a quadratic, we can factor it. Numbers that multiply to 15 and add to 8 would be positive 5 and positive 3, which means the zeros would be negative 5 and negative 3. Always check to make sure it would not make your denominator equal to 0, which they would not. All right, number 18, our last one on our review. First thing you're going to do is look for opportunities to factor your denominator. So this has a common factor of x, so I'm going to go ahead and rewrite it with that common factor taken out. Rewriting the original problem, so we have 1 over 1 minus x minus 2 over x equals x minus 3, and I'm going to use the factored form. So talking about a common factor or common denominator, this one could use an x plus 6, so I'm going to put that in the numerator. But our first fraction needs everything. And then once you have a common denominator, you can just write your equation across your numerator. So that would be x times x plus 6 minus x minus 2 times x plus 6 equals x minus 3. So I'm going to distribute the x, so x squared plus 6x. Now be careful here because we're going to be subtracting whatever we FOIL. So when we FOIL these together, we get x squared plus 4x minus 12. But we have to actually subtract all of that. So it would be minus x squared minus 4x plus 12. So the x squareds cancel each other out. 6x minus 4x is 2x plus 12 equals x minus 3. I'm going to subtract this x over, subtract this 12 over, and I'm getting x equals negative 15, which would not make any of the denominators equal to 0. So that is your test review for your Unit 6 test.